Today I will be working out the problems on the short practice final exam, which is posted on the class website. So go ahead, pause the video and open up that file, and we will start talking about the different problems that you can see. The first problem says that AutoZone operated 3,483 stores in 2004. By 2007, AutoZone operated 4,056 stores. Assuming the number of stores followed a linear pattern, find a model that represents the situation. So we are going to let X equal the number of years since 2004 and Y be the number of stores in operation. So this gives us 2 points. In year 0, we have 3,483 stores. And then in 2007, so that would be 3 years later, we have 4,056 stores. Since this is a line, we are going to use linear functioning to find the equation of the line that contains these 2 points. We will use our slope formula, which is m equals y2 minus y1 divided by x2 minus x1. We will label one of the points x1, y1. The other point is then x2, y2. So this formula actually becomes 4,056 minus 3,483 divided by 3 minus 0, or just 3. And so we get 191. So that will be the slope, 191. Now it asks us for an interpretation of that slope. That is the number of new stores that opens each year. So if this linear pattern continues, 191 new AutoZone stores are opening per year. Now to find the model, we take that 191 that we have there, and then we apply that using the slope-intercept form, y equals mx plus b. We plug in, we already know the b value because of how we set up the problem. That 3,483, since I made that x0, that's our b. So the model is then going to be y equals 191x plus 3,483. The last part of the question asks, according to the model, how many stores will AutoZone, the next part, AutoZone have in 2015? So since 2004 was 0, 2015, that would mean that x equals 11. So I just plug that in. So y equals 191 multiplied by 11 plus 3,483. And we see that the answer is 5584. The last part says, according to the model, when will AutoZone have 10,000 stores? So there we set that 191x plus 3,483 equal to the 10,000 that we are looking for. We subtract 3,483 from both sides. And then we take that result and divide by 191. So that gives us 6517 divided by 191. So that's going to be 34. Since this is the number of years since 2004, our answer ends up being 2038. So we have f of x equals x squared plus 6, g of x equals x minus 8. We are asked to first find f plus g of x. Remember, you can be asked to add, subtract, multiply, or divide functions, so you should know how to be able to do each one of those. There are examples of each one of those in the larger review packet that I gave you. But here, that just means we take f of x plus g of x, so that would be x squared plus 6 plus x minus 8, x squared plus x, combining my like terms, minus 2. That's all there is to that one. Then we have the f of g of x, f of g of x. And remember, that same problem could have been written f of g of x. They both mean the exact same thing. Here we are going to take g of x and we are going to plug g of x into x. So that's going to give us f of x minus 8. So everywhere in the original problem we had an x, we will put x minus 8. So that will be x minus 8 squared plus 6. We square that out. That gives us x squared minus 16x plus 64 plus 6. And so our final answer would be x squared minus 16x plus 70. All right, so here we're asked to analyze this function, the degree. Remember, that is the largest single-termed power that shows up, so that degree is 7. The lead coefficient is the number that is the coefficient of that lead term, so that's going to be negative 5. The maximum number of x-intercepts, that is always the same as the degree. That will be 7. The end behavior. Now, the end behavior is determined by two things. First, we look at whether the lead coefficient is positive or negative. Since the lead coefficient is negative, we know that to the right, the function is going to go down. And since the degree is odd is opposite, so the end behavior to the left will be opposite that of the right, so that's going to go up, then down. Our y-intercept, that is the value of the constant, so that's going to be the point 0, 2. And then our maximum number of turns, that is determined again by the degree of the polynomial. Since it is a degree 7, the maximum number of turns is that degree minus 1. So we have a maximum of 6 turns in this polynomial. So the polynomial function has been factored as much as possible. Find all the zeros, both real and imaginary, along with their multiplicities. Create a rough sketch for the function. So first, to find the real zeros, since this is already in factored form, we can see that we have real zeros here, here. Then with this part, we've got some irrational zeros. We have 2 of them. We will look at this a little bit more in depth. And then this is where our complex or imaginary zeros are going to come from. But to start off with these 2, so we have x plus 1. We take that factor, x plus 1, set it equal to 0. That means x equals negative 1. Then the multiplicity, that is the power that is taken to. So that's going to be negative 1 with a multiplicity of 2. The same idea, we take that x minus 3. So we take the x minus 3. We set that equal to 0. So we know that x equals 3. Since that is to the 5th power, we know that that has a multiplicity of 5. Now the other 2 parts of this are a little bit more complex, but they're not horrible. We have the x squared minus 5. So if x squared minus 5, we take that and set it equal to 0. X squared minus 5 equal to 0. That gives us x squared equals 5. Taking the square root of both sides, we get that x equals the positive or negative square root of 5. Each with a multiplicity of 1. So this x was to the second power, but once we break it down, that x squared minus 5 actually resulted in 2 roots, each of multiplicity 1, rather than 1 root of a multiplicity of 2. The last part that we have to deal with is that x squared minus 2x plus 4. Since we are told it's already in fully factored form, we know we can't reduce that anymore. So I'm going to solve this using the completing the squares idea. So x squared minus 2x plus blank equals negative 4. We take half of negative 2, that would be negative 1. We square it and add it to both sides. So that gives me on this side x minus 1 squared equals negative 3. Taking the square root of both sides, we get x minus 1 equals the positive or negative square root of negative 3. Whenever we have a negative inside of a radical, it comes out as an I, the imaginary number. So that gives us x equals 1 plus or minus I root 3. Now those are 2 additional roots. It then asks for a rough sketch. This imaginary piece, we do not include that in the rough sketch. The imaginary roots do not have any effect on the zeros of this graph. So what we need to do is come over here and we say, okay, we've got 1, 2, 3, 4 real roots. So I'm going to put all 4 of those on my graph. The square root of 5, don't need to know the exact value of it, but the square root of 5 is right about 2.2. So if I've got 3, there would be the negative square root of 5. That would be 1. That would be the positive square root of 5. Now, since this is this an odd or an even function? Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is an odd function. All of the coefficients are positive. So since we are odd and positive, we know that our end behavior is up and down. Negative 5, that is a multiplicity 1, so it cuts through. Then we come to negative 1. I should have a negative on that. Sorry about that. Doesn't change its position. That negative 1 has a multiplicity of 2, so it's going to bounce. The square root of 5, again, has a multiplicity 1, so it's going to cut through. And then 3 has a multiplicity of 5, so it is going to cut through, but it's going to flatten out at 5. It's not going to go directly through. It's going to kind of flatten out, and then it's going to go on up. So that is the rough sketch that we are looking for.